Everybody. So this is my still pretty crude peak finder and synthesizer. Go through some of the things I tried to implement and also some bug that I think is causing problems for me when I transition to a new frequency bin to synthesize. There's some clicking, jagged sounds that I have not been able to get rid of, but otherwise the phase is stable if I am just still in the same frequency bin as a prior frame. So anyway, so I'll get to that later. So basically what we have over here, this information order is going to be our number of peaks. I'm going to keep them low just to prove a couple points at the moment, and also because if I make them higher, there's going to be a lot of printed information in this console over here, and it's going to suck up all our CPU. All right, so good. Here is our actual FFT size, which is of interest, and this is our actual frame size when it comes to samples. So there's a factor of padding that's probably about, I think at this point, 3 times rounded up. Great. Okay, so basically, to start off with, I have no problem resynthesizing sinusoidal frequencies, which I'll do right now. The problem becomes when we actually want to change them. So here's a quick example. Okay, and we'll have our order should be 2. Okay, and we'll switch it over here. All right, great. So this is actually our sine resynthesized. Okay, 50 hertz, no problem, no clicks or anything like that. We can point out one thing that's odd though here. Okay, so if we look here at our phase, notice that the source phase is pretty much centered. Okay. The odd part is though that it is centered on 50 hertz, which is also our frame rate, 50. Okay. We would expect it to be centered on a multiple of our center bin, like for example 5.3, 10, 16, not exactly 50. Okay. So one bug perhaps with my implementation is that for whatever reason in my API where I take in the audio from MaxMSP and I perform all the FFT routines on it, it seems to be affected by the frame rate. And that is causing us not to actually be centered over frequency bins with the phase, but over the frame rate. Okay, so to prove that, see we have our source phase. This is literally, this is not my reconstructed phase. The reconstructed phase is the norm phase. The source phase is the actual phase from the input at that position. I'm just running it through the A10 to function. Okay, so here we see that this is centered over, again, at that time we had 50 hertz, which is the same as an order of our frame rate, and if it was 100, it would be centered again. However, let's change it to 1, or even 10, whatever, 3, 16, anything, okay? And try again. All right, and now you can see that our source phase is no longer centered, though we would expect it to be centered over that bin. So I think that this has caused some problems with me. I've adjusted the phase to compensate for the frame rate instead of the sampling rate, which would give us our bin centers. I chose the frame rate as the way we sum our phase angles. Okay, and this works okay for non-changing frequencies, but watch, if I start to change, you'll notice that it is no longer such a good option. Okay, so let's go back to sure that every time we change index, it's going to click. Gives us a unpleasant clicking sound. And I haven't been able to get rid of that, which is otherwise holding back what I think is a pretty nice, simple, and computationally efficient implementation for synthesizing peaks. Hopefully I can figure this out. I'd really like that. Okay, so let's have a look at a couple things, other things I implemented real quick. Okay. And then I'll wrap it up. Okay, good. So I have a couple different modes here. Okay, and it'll be clearer if I introduce another tone. Okay. Great. So that's the nearest neighbor mode. It's just going to, we're only going to search for 2 peaks. And I have a peak threshold of 10. Magnitude is over 10. Some arbitrary number, but it seems to do good enough for getting rid of minor false peaks. Okay. Another mode I did though is, you'll see here, if I add noise, okay, that the nearest neighbor one quickly runs out of space because it's only searching for right now an order of 2, and it's not going to make it to the end of the Nyquist, so they're going to kind of cause each other to kind of compete in a way that we might not want. So I put a secondary mode where I break the search into, I partition the search into the entire range of Nyquist. So right now we have an order of 2. That means we're going to split Nyquist into the frequency range into 2. So one to say 10,000 or 11,025, because we have 44,100 hertz. And then the second group is from 11,025 hertz to 22,050 hertz, which is our Nyquist frequency. Okay, so here now I split this. Okay. And we get a kind of different kind of competition because both of these are actually below our the split. So we have 2 competing frequencies now within the same partition. Okay, so this will obviously improve if we have a higher level of order. Okay, which I'll show in a little bit. The second mode is actually the same as the one I just showed you, where we partition Nyquist, but we do it according to the Mel scale. So we have a finer focus on the lower frequencies. Okay, so I'll kind of give an example of how that works. Okay, so this is without the Mel. This is with the Mel. And you can see that we have better focus on lower frequencies when we have the Mel scale. Okay, so even with an order of about 16, gives us enough difference between, say, 220 hertz and 330 hertz. So that's kind of neat, I guess. And that's basically where we're at right now. For voice, it's pretty bad. You can hear, well, it does an okay job finding peaks. You can see we're going to have a lot of clicking sounds because of that phase transition, that bin transition problem I had described. Okay, so anyways, I hope to fix that. That would be great. Thanks for listening.